Okay, this is my Chapter 5 reassessment. I did a problem executing the use of the acceleration on a circular motion. It says, what is the minimum speed necessary to complete the loop-de-loop with a car that's 1.5 meters high and a radius of the loop-de-loop is 6 meters. So I've drawn the loop-de-loop here. The car would be going around the loop-de-loop in this circular motion. It's a bad circle, but we know that there are perpendicular accelerations on the car going inward into the circle, and they're forming right angles that I've drawn, and we're actually going to be measuring the acceleration down, or the speed at the very top of the circle, which is when it would have the strongest force pulling down on it, because that's when gravity is acting strongest on it. So I've drawn that there's a force of the mass times the gravity pulling downward in on the circle, and the car would be moving around the circle in that direction. So we would use the equation acceleration of the circle equals v squared over r. So we know the acceleration is going to be 9.81 meters per second squared equals v squared over 6 meters. So we can rearrange that and solve for v. So we have v squared equals ac times r. Take the square root of both sides and you get v equals the square root of ac, the acceleration of the circle, times r, the radius. So we solve for v and we get v equals the square root of 9.81 meters divided by a second squared times 6 meters, and that is approximately 7.7 meters divided by seconds. So that would be the velocity at the very top of the circle, which is the very minimum speed which it needs to get around the loop-de-loop. And we can convert that into kilometers per hour, which is, what we're used to when driving a car. So I multiplied that by 3,600 seconds in an hour times 1 over 1,000, because there's 1 kilometers in 1,000 meters, and that gives you approximately 27.6 kilometers per hour. And then I went further to say, what is the average velocity of the loop-de-loop? So say that the time it took for the car to get around the loop-de-loop one time at this velocity was 2 seconds and 14 frames in a 30th of a second. And we know the circumference is 2 pi r, and we know the radius, so we can solve for that. 2 pi times 6 meters would be 12 pi meters. So we can get the average speed by doing 12 pi meters over the time, which is 2 and 14 over 30 seconds. And we would get 15.3 meters per second. And again, we can convert that to kilometers per hour by multiplying by 3,600 seconds per hour times 1 over 1,000 kilometers per meter. And that would give you approximately 55 kilometers per hour. And that demonstrates how to find speed and velocity when dealing with circular motion.